We now look at basic trigonometry. There are three basic trigonometric ratios we must be knowledgeable about. They are cosine theta, sine theta, and tan theta. The following acronym helps us to remember how these ratios are made up and applies for all right-angled triangles and only right-angled triangles. The acronym that we will remember is SOHCAHTOA. SOHCAHTOA, which means that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent or tan opposite over adjacent. Sine theta opposite over hypotenuse, cosine theta adjacent over hypotenuse, tan theta opposite over adjacent. This is our general triangle, and in our general triangle there are certain things that we need to know about, and those things are as follows. The vertices are labeled A, B, C, capital A, B, C. Alright, now these could be any letters. It could be P, Q, R, L, M, N, any combination, but they are actually capital letters. Now, the corners or the angles at each of these vertices are designated by the same capital letter, in this case A, with a hat on top, a little hat. Then, in this case, capital C with a little hat on top would designate this angle, which is at 90 degrees, which is what we need for these particular triangles to use the trigonometric ratios. And this one is capital B with a little hat, because it also designates the angle at the corner of vertex B, this angle here. Now, opposite each of these angles, for example, opposite angle B would be the side whose length is common B in length. That side will be AC. Opposite angle A will be a side whose length is common A, designated by this common A here, and that will be length CB. And opposite angle C will be a side whose length is common C in length, and that side is AB. Okay, so that is the general nomenclature, or the general way in which we label triangles, vertex being the capital letters and the lengths opposite the vertices being the common letters. Now, in order to be able to identify and to work with these trigonometric ratios, we must understand certain key concepts. The first one is that the hypotenuse is always the longest side and the side opposite the right angle. So in this triangle, the side opposite the right angle is this side here, which is AB, and that's the hypotenuse. It's always the longest side. The adjacent side is the side nearest the angle being considered. In this case, if theta is the angle being considered, the adjacent side will be the side next to it, which will be the side AC, and the opposite side is the side furthest from the angle being considered. In this case, if theta is the angle being considered, the opposite side is, if we follow the arrow, the side furthest away from it, and that is the side CB. Now, let us look at a typical triangle and see if we can pick out what the sine, the cosine, and the tan of the specified angle theta will be. Sine theta is opposite over hypotenuse. In this case, opposite is AC over hypotenuse, which is opposite the right angle, which will be AB. So it's sine theta is opposite over hypotenuse, which is AC over AB. Cosine theta will be adjacent, which is this side here, CB, adjacent, CB or BC, same thing, over hypotenuse. What is the hypotenuse? Hypotenuse is always opposite to the right angle, which will be AB. So cosine theta will be adjacent over hypotenuse, which is equal to BC over AB. Then we look at tan theta. Tan theta will be opposite over adjacent. Opposite to this angle will be AC, hence you have AC over adjacent, which is next, the side closest to it or next to it, which is not the hypotenuse, but the side closest to it will be CB. So tan theta is opposite over adjacent, which is AC over CB. In this case, we have a different orientation of the triangle. Theta is as shown. Sin theta, opposite over hypotenuse, opposite. Furthest away will be xy. Hypotenuse is opposite the right angle, which will be the side xz. So opposite over hypotenuse will be xy over xz. Next, cosine theta is adjacent, which will be this side here. Next to it, yz over hypotenuse. Hypotenuse is the side opposite to the right angle, which is this side, which is xz. So cosine theta is adjacent over hypotenuse, or yz over xz. Tan theta, opposite over adjacent. Opposite over adjacent. Opposite is xy. Adjacent is yz, so it's xy over yz. And now let us look at a few examples. Let us consider sin theta. If we have to find this particular angle, then we have to be able to identify which ratio we're going to use. Now, the secret is to look at the angle that you have, look at what you want to find, and look at what you have. Now, in order to find sin theta, which is the angle, we notice that we have opposite and we have hypotenuse, which is opposite angle C, which is a right angle. Sin theta is opposite over hypotenuse. Sin theta is opposite over hypotenuse. Opposite is 3, hypotenuse is 5. So sin theta will be opposite over hypotenuse, which is 3 over 5. When you work that out, that equals to 0.6.